Hi, my name is Josh Bruno, and this is my presentation on Six Sigma. Six Sigma is a methodology used that strives for perfection. It's highly seen in manufacturing as well as transactional um, industries. So, yeah, Six Sigma is a style. It makes use of hypothesis testing, more specifically a two-tailed hypothesis test. And basically, given your average result or your mean, um, and by choosing your specification levels, the range that you would like to keep your results in, um, you can calculate the needed variation or standard deviation that would result in near perfection. So to calculate this range and required standard deviation as well, you basically do just this. Um, you're given your average through just sampling. You can figure that out, as well as your current standard deviation, and then you choose your high specification level and your lower specification level. And as you can see here, given this just the standard z-score equation, you're going to take and figure out you can rearrange this equation and figure out the required standard deviation so that your specification levels result in the specification levels being 6 standard deviations away from your mean, and that is important because doing so would leave your confidence level to be very high. As you can see here, your level of significance, or the chances of an outlier of that range, would be 0.0000000197, which is rather small. And then after finding that required standard deviation, what you do then is find out what your critical levels must be, which is going to be 4. It's actually with a 6. So your level, your significance level, minus 1.5 standard deviations. So that would put your critical level at 4.5 standard deviations. And as you can see here, you still have your significant levels here at 6, outlying the 6 standard deviation, and then here is your critical levels. And the purpose of this is, well, as you can see here, the chances of a result falling into there now is going to be 0.00, when your critical level is going to be 0.00068. And the importance of that is that you have a 3,451 more chance. It is 3,451 times more likely for a result to land in your critical level than it is for your outlier. So the purpose of that is, once you do get a result in your critical level, you then know you need to take some action. And then through those results, you can figure out the required variation of, the required standard deviation to hit the perfection that you are striving for. And now, how this could be applicable in school, I would say is likely most applicable in participation as well as homework. You could set your you figure out your average student's participation, or even just their average grade on the homework. Figure out then where you think every grade should, where you want all the grades to result, and that would be those grades um, that you want every grade to be within would be your significant levels. And at that point, given those, if you can then calculate the needed standard deviation, and then after that you can get your critical levels, and then obviously if anything falls outside of those critical levels, or students' grades or participation falls outside of that, you should take some correction with that student. Thank you, and thanks for listening.